Good day to everyone. So in this video, we're gonna discuss all about the linear programming using the linear inequalities, geometry of linear programming, and in simplex method.
Hi, I am Linus Joseph and I will be presenting to you linear programming. So let's start with the introduction. What is a linear programming? Linear programming is a powerful method for optimizing decision making, and in this presentation we will provide an overview of what is linear programming. Second is to understand what is linear programming. Linear programming is a mathematical method for determining a way to achieve the best outcome in a given mathematical model. It involves maximizing or minimizing a linear function subjected to a set of constraints. Here are a basic example of a linear programming. Maximize or minimize z equal to 5x plus 4y subjected to the constraints of 4x plus y equal or greater to 40, 2x plus 3y equal or greater to 90 when x and y is equal or greater to 0. So let's solve for our constraints of 4x plus y is equal or greater to 40. And let x be 0, we got y is equal to 40, and we let y equal to 0, we got x is equal to 10. So let's go to our second constraints, which is 2x plus 3y is equal or greater to 90, and we let y equal to 0, we have 45, and we let x 0, we have y is equal to 30. So here is the graph of our solution based on the constraints that we have just solved. Now let's go with the solving for the intersection on the graph. On our first constraints that is 4x plus y is equal or greater to 40, we want to remove the y from the equation, so we can use the negative 3 to multiply them. So the answer will be negative 12x plus 3y is equal to or greater to 120 minus our second constraints, which is 2x plus 3y are equal to greater to 90. So we have the final answer of x is equal to 3. Now we have our x, which is 3. Now we can use it on our first constraint, which is 4x plus y is equal to or greater 40. So we substitute x to 3, we have 4x plus y equal or greater to 40. Now the answer is 12x plus y is equal to 4 equal or greater to 40. Then we have our final answer of y being 28. Welcome to the last step in solving our equation of z is equal to 5x plus 4y, in which we will find the maximum and the minimum. First, we can make a table where we can place the point which we have gathered in the previous slides, which is 0, 0, 0, 30, 3, 28, and 10, 0. Next to it is our z, which is 5x plus 4y, and under it is the answers, which we can simply substitute x and y basing on our point. So we have 0, 0 is 0, 0, 30 is 120, 328 is 127, and 10, 0 is equal to 50. Now we have complete our table. We can clearly see or find that our minimum is 50 and our maximum is 127. And that would be the final answer of our final equation of the equation. And that would be all. Thank you for listening.
A pleasant day to all you guys. For today's video, I'm going to explain to you about the linear inequalities. What is linear inequalities? Linear inequalities are the expressions where any two values are compared by the inequality symbol, such as less than, greater than, less than or equal to, or greater than or equal to. Linear inequalities are inequalities that involve at least one linear algebraic expression, that is, a polynomial of degree 1 is compared with another algebraic expression of degree less than or equal to 1. A linear inequality seems exactly like a linear equation, but there is a change in the symbol that relates to expressions. To understand furthermore about the topic, let's try solve this one. We have 2x 3 greater than 7. In this equation, we can use this greater than equal into equal. To get the answer, we need to get rid this 3. So we need to put 3 then as well here. Then we'll bring down the 2x. Then positive 3 minus negative 3 is 0, so we don't need to put down. Then here is 7 minus 3 equals to 4. So that we can get our x, we need to divide this by 2. As well here, we put 2, then cancel out. Then we bring down 2. Oh, don't forget to put the symbol greater than. So the 4 divided by 2 equals to 2. To plot this, then the 1 and 2. X is greater than 2, so that we're going to circle here at 2. The symbol is greater than 2, and that's why we're going to shade to the towards right. To represent the answer using the interval notation, it's form 2 to infinity. Another example, we have 1 over 3x plus 4 less than or equal to 6. To get this, as well as like the first problem, we need to read this 4, so we're going to subtract it by 4. So here, then we're going to bring down our x, 1/3 over x. Then 4 minus 4 equals to 0, so we don't need to put down. And here, the 6 minus 4 equals to 2. And don't forget the symbol less than or equal to. As you can see, the 1/3 is a fraction, so we need to remove this fraction by multiplying by 3 as well here. But 3 times 1/3 equals to 1, but we don't need to put the 1 anymore, so we're going to put the x symbol less than or equal to, and the 2 times 3 is equals to 6. To plot this, I'm going to shade here. The symbol is less than or equal to. That's why we're going to shift to the left. To represent this answer using the interval notation, our answer will be negative infinity and Now, I'm going to talk about the linear inequalities graphing. The linear inequality graph divides the coordinate plane into two parts by a borderline. This line is the line that belongs to the function. One part of the borderline consists of all solution to the inequality. The borderline is dashed for inequalities greater than and less than, and solid for greater than or equal to and less than or equal to. Later on, I will explain to you about this dash and the solid line. Now, let's try to solve this graph. We have x greater than 3. To graph this, we need to and put 1, 2, should be bigger for x and right here. But problem is the x is greater than 3. To this, our 3 will be here. The line we're going to use will be the dot line because it it's less greater than. Another example, we have x less than or greater less than 2 or equal to negative 2. I'm going to graph this. We have our 2 here. The sign is the less than or equal to. So we're going to use the solid line. And because solid, we're going to shade part here. What if y, we're going to use the y, is greater than negative 2? To graph this, we're going to graph and here's our negative 2. The symbol we use are greater than, so we're going to use the dash line. It here says that y is greater than negative 2. So the part we're going to shade is going towards up. That is. Another example, what if our y is less than or equal to 2? To graph this, we're going to here's our 2. The symbol we use are less than or equal to, so we're going to use the solid line. In this problem, the y is less than or equal to 2. So in this problem, we're going to shade below what if we have problem this y is greater than x minus 2. This equation is in slope intercept form. So we're going to use the y equals to mx plus b, where m represent the x is 1, and our b is the -2. To graph this, could put here our in y-intercept and our x. Our y is -2. Our y is -2. Sorry. Our slope is 1. By the using of the rise and run, we're going to rise our rise and run are 1, and the rise and our rise here. We're going to rise here, run, rise, then run here. So our next dot here will be here and here. This method and so on here. In this problem, the symbol is greater than, so we're going to use the dash line. In this problem, y is greater than x minus 2, so we're going to shade the another sample problem. Y is less than or equal to minus 3. With the same method, we're going to use the y equals to mx plus b, or m will represent 2 and b -3. And graph this. Our y is -3, so we're going to shade here, shade. By the using of rise run method, there's rise run method. Our m is 2, so we're going to rise run equal 1. Our y is 3, so here. To get the next dot, we're going to rise 2, or here 1, 2, then run 1 here. As well here, rise 1 and 2, then run 1. Here, rise 1 and 2, and run here. And so on. Symbol we use are less than or equal to, so we're going to use the solid line. In this problem, the y is less than or equal to 2x minus 3, so the shading part will be below. And that's it. That's the simple problem we can solve in linear inequalities.
Good morning, good afternoon, everyone. My name is Mujunay Jungdani from BSIT1A. Today, we are going to talk about geometry of linear programming. Real-world problem can be solved through linear programming. Before one can solve the problem through linear programming, it must be translated into a mathematical equation. This mathematical translation is called a model. So, every linear programming problem has three components: variable, object, and constraint. Variables are the quantities that may vary in a problem. In a linear programming, the objective can only be minimization or maximization. And the corner principles state that the maximum and minimum value of an object function occur at corner points of the region of possible solution if that region is bounded. This step to follow in using graphical method. Number one, present the unknown in the problem by using decision variables using any letter. Number two, if necessary, tabulate the unknown data. Three, formulate the objective function and the constraints. Four, graph the constraints and find the feasible region. 5. Substitute and coordinates found in the feasible region. 6. Determine your solution by selecting the highest value maximization or the lowest value minimization. Word problem. The McDonald's wish to produce two types of hamburger, double burger and cheeseburger. Each double burger of hamburger will result in a profit of 80 pesos, and each cheeseburger of hamburger will result in a profit of 50 pesos. To grill a double burger required 8 minutes on a grill A and 5 minutes on a grill B. A cheeseburger requires 3 minutes to grill A and 6 minutes on grill B. There are 10 hours available on grill A and 8 hours available on grill B. How many hamburger of each type should the McDonald's make in order to maximize its profit? Number one, make a presentation in tabular form. So let x equals to double burgers and let y equals to cheeseburger. So this is the tabular form, no? So hours times 10 hours times 60 minutes equals to 600, and 8 hours times 60 minutes equals 480. So objective form, P is a profit. So P equals to 80x plus 50y. Constraint. So 8x plus 5y is greater or less than or equal to 600. 3x plus 6y is less than or equal to 480, and x is less than or equal to 0, and y is less than or equal to 0. So find the corner of vertices. So let x equals to 0, no? So 8x plus 5y equals to 600. So 8 parenthesis 0. So yung x natin ay 0. So 8 parenthesis 0 parenthesis plus 5y equals to 600. So 8 times, so 8 times 0 equals to 0. So wala na siya. So 5 na lang. 5y equals to 60 na lang na. So i-cancel out natin yung 5. Ito. Cancel out natin yung 5. Tapos may iwan dyan ay y. So 600 divided by 5 equals 120. So yung ordered pair niya ay 0, 120. So let y equals to 0. So, ganun din yung procedure. 8x plus 5y equals to 600. 8x plus 5y, parenthesis 0, parenthesis equals to 600. So, 5 times 0 equals to 0. So, 8x, 8x equals to 600. So, 8x bring down 8. Ilagay natin dito 8. Dito, maglagay tayo 8. Tapos i-cancel out siya. Cancel out. Tapos ang matitira na lang ay 6. Ang matitira na lang ay x. X. No? So, 600 divided by 8 equals to 75. So, ordered paired ay 75, 0. So, dito naman tayo sa 3x plus 6y equals to 480. So, let x equals to 0. So, 3x plus 6y equals to 480. 3 parenthesis 0 parenthesis plus 6y equals to 480. So, 3 times 0 is equals to 0. No? 6y equals to 480. So, 6y, we put here 6. So, cancel out natin yan. Cancel out. Cancel out. So, yung matitira ng y equals to 480 divided by 60. So, 480 divided by 60 is 80. So, y equals to 80. So, ordered paired ay 0 and 80. So, dito sa baba, let y equals to 0. So, 3x plus 6y equals to 480. 3x plus 6 parenthesis 0 equals to 480. So 6 times 0 equals 0, no? So, 3x equals to 480. So, 3x, ilagay natin yung 3 sa baba. So, 3 para ma-cancel out din siya. So, x equals to 480 divided by 3. So, 480 divided by 3 is 160. So, x equals to 160. Ordered pair ay 160 and 0. No. Number 2, graph the points and state the feasible region. So, i-graph natin siya. Yung kanina ay, di ba, may dito. So, ordered pair niya ay, wait lang. Ito, ito, 0 and 120. So, dito ay nakikita nyo naman sa 0, 120. Ay, mali. Blue line natin ay 8x plus 5y equals to 60. At yung orange line natin naman ay 3x plus 6y equals 480. Tapos, determine the feasible region. Assume that x and y are equal to 0. So, 8x plus 5y less than or equal to 600. So, 8 parenthesis 0 parenthesis plus 5 parenthesis 0 less than or equal to 600. So, 0 less than or equal to 600 is true. Tama. Totoo. True. 3x plus 6y less than or equal to 480. So, 3 parenthesis 0 parenthesis 0 plus 6 parenthesis 0 parenthesis less than or equal to 480. So, 3 times 0 equals 0. 6 times 0 is 0. So, 0 less than or equal to 480. So, true. So, since pareho silang less than is true, syempre, pagka true, yung direction of shade natin is papuntang 0. So, papunta po siya dito. Pag ano. So, meron tayong tatlong vertices. Ito, saka ito. So, So ngayon, no, so dito ay hahanapin natin yung point of intersection sa dalawang line, yung orange at saka blue. So 8x plus 5, y equals to 600, and 3x plus 6, y equals 480. So, yung gagamitin natin pala dito sa pag-compute ay elimination method. So, ito siya. So, 3x plus 6, y equals to 80. Ay, mali. Okay. So, 8x plus 5, y equals to 600. Ito na yan. So, lalagyan lang natin dito ng parenthesis para matanggal yung y. So, negative 6 of 5. So, yung negative 6 times 8, 6 times, negative 6 times 8x equals 48, negative 48x plus 6, negative 6 times 5, 5y equals negative 30y equals, so negative 6 times 600, so equals to negative 3,600. At yung 5 naman natin, 5 times 3x equals 15. 15x plus 5 times 6y equals 30. 30y equals 5 times 480 equals 2,400. So ngayon, pwede na natin ma-eliminate yung y. So, eliminate natin, tatanggalin natin to siya. Y, so matitira na lang ay negative 48. 48x equals negative 3,600. And 15x equals 2,400. So, negative plus 15, so 33, negative 33, negative 33, and negative 600, 3,600 plus 2,400. So, negative 1,200. So, 1,200. So, para negative 33x equals to negative 1,200. So, negative 33x equals to negative 1,000. Hindi na kasya. Equals to negative 1,200. Negative 33x pala. So, negative 33. So, tanggalin natin yan para makuha natin yung x. 33. 33. Lalagyan natin. So, ay alisin natin yung 33, like eliminate. So, 33, di ba, 1,200 divided by 33 is 36.3. So, x equals to 30, oops, 6. 30.3. Ito yung Sagot natin sa 8x plus 5y equals to 600 and 3x plus 6y equals to 480. Ito yung sagot natin. So, dito naman tayo sa kabila. Wait, reset. 8x plus 5y equals 600. So, meron naman tayo dito sa x. So, yung x natin dito ay magiging 8x parenthesis 36.3 plus 5y equals to 600. 8 times 36.3 is 200. 90.4 plus 5y equals to 6. So, yung 190.4 ay lilipat natin dito sa 600. So, yung kalabasan niya ay ganito. 5y equals to 600. 600 minus 193. So, 5, wait, parang 6 na siya. Dito na lang siya. So, 5y equals to 600 minus 29.3 is 20, 61. No. To maximize the profit of McDonald's, may opt to grill a 75 minutes double burger or 36.3 minutes double burger and 61.92 minutes in cheeseburger. To maximize of the profit at the point of 36.3 and 61.92.
Hello everyone, so I'm Siti Aisam Sal Ibrahim and I'm gonna discussing the linear programming using the simplex method. Okay, so first we will define what is that simplex method. So simplex method, that is a standard technique in linear programming for solving an optimization problem, typically one involving functions and several constraints expressed as inequalities. The inequalities define a polygonal region and the solution is typically at one of the vertices. The simplex method is a systematic procedure for testing the vertices as possible solutions. So, as you can see, the maximize z is equals to 7x1 plus 6x2, that is the objective functions, and the constraints is that the subject to x1 plus x2 equals to less than the 4, and the non-negative constraints is that where x1, x2 is equals to greater than 0. So, moreover, before we go into create a table or find the private column, first things to do, we have to convert the inequalities into the equation and adding the slack variables. Okay, so later we have a problem and we're trying to solve it by applying the procedures that we have here. Okay, so here are the procedures that we're going to apply, and let's have problems. Okay, so here are the problems, and that's that 3 procedures that we're going to apply first. So first things to do is that to convert the inequalities into equations. Okay, that is 4x and the y, and by adding the plus q, that is the r slack variables, and the 4 equals to 40 to make that equations instead of inequalities, and that 2x plus 3y plus w. Okay, so w is another is like variables that we add and equals to 90. So we don't need to worry about the x, y less than equals to 0 because they're included in the simplex method, and this one we will write it to remove anything over to the left hand side because we want 0 on the one side and we want z to be positive equals to 0. Okay, so let's create initial table. Okay, and then label the active or basic variables, that is x, y, u, v, and z. Okay, so let's write the what is x, that is 4, then 1 is that understood to have 1 here, then 1 is u, w is 0 because there's no w and z on the first constraint, and then okay, 2 that is 2x, and the 3 is y, and then the u is there's no u and z on the second constraints, and then okay, so the next that is -5, and then -4, and u is 0, w is 0, and z is 1 and 0. Okay, next we have to select the private column that is the most negative number. It is the under column x, and we have to divide the 4 and 2, that is the corresponding positive entry in the private column. Then 4 divided by 4 equals to 10, then 90 by 2 is that 45. Okay, so next we have to find the maximized, and okay, take note the maximized that is equals to the most negative. Okay, sorry, erase it, and okay, most negative lang, and minimize that is the opposite of the max, that is the most positive, but we are solved for the maximize, so we have here that is 10 is the maximize because it is the the last number, and I'm gonna write here the r1 is equals to 1/4 because we divide it by 4, and to make that 4 into 1s. Okay, so another page, we're going to perform row operation to make the private equal to 1 and the remaining elements in the private column equal to 0. Okay, let's create another table. See. Okay, again, what is that row 1 again? Okay, so we are dividing that by 1/4. Okay, so that will be 1 and 1/4. Then also here 1/4, 0, 0, and cents. Okay, so just copy the row 2, that is 2, 3, 0, 1, and 0, then 90 over. Then also the row 3, then that is -5, -4, then 0, 0, 1, 0. Okay, so we're going to make this 2 equals to 0 because we have the 1 already. We have here the row 1, row 2. We use the minus signs. Okay, 2 and r1. Okay, and also to make this -5 equal to 0, we have here the row r3 that is negative. If I use the positive sign, then 5 and r1. Okay, so let's make another table okay, x1, then 2. Okay, sorry for that. Okay, y, q, w, then z. Okay, let's copy the first row. 1/4, 1/4, and 0, 0, 10, 10. Okay, so let's perform the we create the formula for the row 2, that is R2 minus 2R1. Okay, what is the R2? That is 2, 3, 0, then 1, 0, and 90. Okay, minus signs. Minus, then 2 by 2 and minus by 2. And times by the row by row 1, I meant, sorry. Okay, so 1, that is 1/4, and same here, 1/4, then 0 by 0, and then equals, to get the result, equals 0, that must be 1, 0, then 5/2, then 2/4, 1, 0, and that must be 70. Okay, so wait, that I'm going to write that. Okay, so let's write the row 2. Number 4, 1, 10, 0, then 70. Okay, last we're going to use perform the R3 plus the 5 R1. Okay, row 3 again. -5, -4, 0, 0, 1, and 0. Okay, positive sign. Then R1. Ay, sorry. So 5 pala. Okay, add by 5. Then the R1. That is 1, 1/4, and 1/4. Okay, 0, 0 at once, and the 10. Sorry, erase that. 5, 10, 10. Equals to get the result. Oh, sorry, erase it. Okay. Equals. That must be a 5/4, and 0, 1, and 5. Okay, 1/4, 5/4, 1, and 50. Okay, so we're not satisfied yet for our answer, so because the column Y still have the -11/4, and we're going to repeat the process. That is by identifying the most negative entry on the left side of the last row, that is the -11/4, and then let's divide that into 1/4 and the 5/2, and the result is that 40. Okay, so let's make it clear here. Okay, raised. Okay, divide that by 10 divided by 1/4, that is equals to 40, and 70 divided by 5/2, that is 28. So the most last number that is 28, the row 2, and we're going to perform the operations again. Okay, because 28 is that last. Okay, so again, another page. Where is it? Okay, that's right, that's better. YUWZ. Okay, again, what is the row 2? we're going, okay, copy the row 1 first. 4, 0, 0, and 10. Again, where's the row 2? And we're going to divide that by 5 over 2 to make that 5 over 2 equals to 1. Okay. Okay, that must be 0, then 1, then 1 over 2, and 5 over 2, 0, and 28. Okay, 28. I just copied the last row. Is it negative 11 over 4, 5 over 4, 0, 1, and 50. Okay. Next process. Okay, so white color, no red. Okay, to make that 1/4 equals to 1, equals to 0, and the negative 11 over 4 and to equals to 0, we use here. Okay, we have here the R1s, and that positive 1/4, we use the minus sign, and there are 2 row 2, and also here the row 3 to make that equals to 0. Okay, erase. Okay, we have here the row 3, R3, that's negative, we have used the plus signs. Okay, R2. Okay, alright, make it better. Okay, so we use again the procedure 7, and we're going to perform the row operations using the formula. We have that there, and so that is R1 negative 1/4 and R2. Okay, again, what is the row 1? Okay, this one. Okay, erase it. Okay, that's clear. Okay, let's copy the row 1 again. What is it? Okay, this will be 1, 1/4, then 1/4, 0, 0, and 10. Make it better. Okay, minus sign, and by 4, 1/4, 1/4 minus 1/4, and the R2 we're going to sorry for the mistakes. Okay, that is the row 2. We're going to multiply it by here. Okay, R2, that's 0, then 1, then 1 over 2. That is 5 over 2, and 0, and 28. Okay, equal sign to get the result. That must be 1. Then sorry. Okay, that must be 0. This must be 1 over 8. Then negative 5 over 8. Then here's 0, and 30, and 3, I mean, sorry. Okay, let's make another table to write the what we calculate here, and Z. Again, what is the row 2? We just write here the row 2. Okay, row 2, 0. That is 1, 1, 2, 5 over 2, 0, and 28. Make it so white. Okay, 28. Yay. Okay, so We calculate for the row 1 and let's just copy it. No, it's negative y over 8, 0 and 3. Okay. Last one, the row 3. Okay, we use this row. This is for the row 3. Okay, let's. And if this is the formula we're going to use, formula R2. 0 was the R3, that is okay, that is negative 11 over 4. Okay, and 0 and 50. Okay, the positive sign, going to add it because negative 11 over 4 is negative, and we use the positive sign. 11 over 4. Then what is the R2 again? Okay, let's just copy here. Multiply it by R2. 5 over 2, 0 and 28. Okay, calculator. I know negative. Equal signs. Okay, let's get the answer. 0. It must be 0. This must be 21 over 8. And here are the 55 over 8. Then here are 1 and 127. Okay, so let's write it. Okay, so once the left side of the last row is all non-negative, the solution can be found. The value of each row variables or active variables is equal to rightmost entry in the row, all inactive variables equals to 0. Okay, so we made it. Okay, let's now find the x, y, and z. Okay, so x. So row 1 have the 1. It is under the column x, that is 3, and y and the row 2, that is 28. Okay, 28, and z is in the last row. It is 127. Okay, again, what is the maximize we use? It is the z is equals to 5x plus 4y. Okay, so let's distribute here. Okay, let's distribute. The z is equals to 5 times 3, because x equals to 3, and 4 times 28 equals to 5 times 3 is 15 plus 4 times 28, that is 112. Okay, plus 15 plus 122, that is 127. Okay, no, wait, make it better. Okay, 2, 7. Okay, that's better. Okay, and yellow. Okay, so we solve for the max z is equals to 5x plus 4y using the simplex method, and we get the 127, the answer, and it's the same as what Mr. Joseph just explained earlier in the linear programming. And okay, so that's all, everyone. Thank you for watching. Hope you learned a lot from here, and have a good day, everyone.